I'm Nick. According to Moore's law, the amount of computer transistors in a chip will double every 2 years, slightly increasing computing power. But what if there was a material that could increase computing by 1,000 times and reduce energy consumption? This wonder product is known as graphene, and it possesses many unique properties which allow it to outclass almost every other manufacturing material humans have. Today, we will be discussing the discovery, the isolation, and unique properties of graphene, as well as discussing its groundbreaking applications in computing and manufacturing industries. So, what is graphene? Why should I care about it? Well, graphene was discovered by two scientists, Andrew Geim and Konstantin Novoselov at the University of Manchester in 2004. The scientists took a brick of graphite and stuck sticky tape on it, and by doing this repeatedly, they were able to create a graphite flake 1 atom thick. This was the first time graphene was isolated. Now, according to A.C. Ferrari from the Cambridge University, graphene is a super lightweight allotrope of a carbon in the form of a single layer of atoms in a two-dimensional hexagonal lattice. This makes it 200 times stronger than steel, 97% transparent, carries 1,000 times the electrical density of copper, can flex up to 20% without breaking, and is only 1 atom thick. Now that we understand graphene, let's take some look at some of its applications. How can graphene affect the computing world? Well, according to an article in Futurism magazine, transistors follow the law of Dennard's scaling, which dictates the amount of energy required to use in processing in relation to its size. Silicon, as well as copper, are the current materials used in manufacturing computing hardware and can no longer scale down transistor size, as the smaller you go in transistor size, the more energy is required. Silicon's thermal conductivity lies only around 148 watts per Kelvin, while graphene is 3,000 to 5,000. So, according to Nature magazine, graphene's remarkable heat dissipation could allow it to be used in quantum computing. Now, to understand the importance of this, first we must understand how conventional computers operate. By manipulating individual bits, computers store information as binary ones and zeros, while a quantum computer would store it as a qubit. Quantum computers take advantage of the quantum mechanical phenomenon of superposition and entanglement to create states that scale exponentially with the number of qubits. Now, superposition is natural quantum phenomenon described by Schrodinger's equation that allows these qubits to exist as a 1 and a 0 at the same time. This allows quantum computers to solve infinitely more complex problems than a conventional computer could. Now, quantum computing also requires immense amounts of power, which normal materials like copper and silicon cannot do in room temperature, but graphene may be able to. Now, scientists are currently working on ways to create and infuse graphene computing chips, and have come up with a graphene nanoribbon, which would allow graphene to be used in quantum computing. Now, all of this is still in the works, so let's look at some real-world applications of graphene. So how has graphene been already used in our world? Well, graphene is already being used to aid in manufacturing products. It's used by Head Tennis Racket Company to make stronger and lighter tennis rackets. It's used by Passy Bikes as this thing called nanine, which isn't quite graphene. It's a several layer thick graphene platelets, not 1 atom thick, but is used to create a bike frame which is 30% lighter and twice as strong as normal bike frames. Now, while graphene is being used in manufacturing, it is already facing problems with large-scale production, as the process in obtaining a 1 atom thick graphene is not perfected, and due to the hexagonal lattice pattern of graphene, it needs to be air-free, or else all the special properties of graphene do not work. Now, graphene has many necessary applications for the furthering of our technology. Not only can it revolutionize the world of computing, but it's going to change the way we manufacture for the better. So finally, hopefully this gave you some insight on the world of graphene, and have a good day.